Okay, so today's topic, like I mentioned last session, will be around hardware, software, and programming languages. And at the very end, if we still have some time, we will be talking about some processes in the software development in general, not only from the DevOps perspective, in general, software engineers and all the other fields. Okay, and if you still have some questions, it will be the same. I'm gonna stay a little bit longer if needed. So you can ask me the questions if you have any at the very end. Depending on how it goes, and we will see, depending on the time as well, we might cover this last topic here. Any questions so far?
Oh,
Okay, and I would really appreciate actually if you have any questions or when I ask some questions, don't be shy, okay? Just throw it out there, and nobody knows you. It doesn't matter. We are not making any assumptions. So we just think that everyone has no idea about IT or any components or stuff like that. So just make your best guess. Don't be shy. I'm just interested, I'm just trying to make it interactive as opposed to me reading or just talking. Okay. Last lesson, it was great, like I mentioned. So hopefully this will be as helpful and as interactive. Okay, and today, what do we have? So we will be covering the hardware part. I already have a question for you guys. What do you understand when we say hardware? Can you guys name any hardware or components from computers that you might be familiar with? Anyone wants to guess, or if you guys know, you want to contribute here?
Like a hard drive or something?
Yeah, that's a good one. The first one is a hard drive, right? Everyone probably knows.
Yeah, so in my understanding that hardware means like all the computer bodies, motherboard, CPU, hardware, and all those components like mouse and monitor and all that.
Nice. Yeah, Sasha in chat, he's saying that GPU, CPU, SSD, and all that stuff, which is really nice. Those are the things that we call hardware, right? Or in other terms, components of a computer or PC or desktop, laptop, doesn't matter. But it's just some metal parts or plastic parts that make up all those components, right? So if we switch to this picture here, I'll be talking about over all of these components right now, and then I will actually show you the actual pictures of those, how they look like, and we will deep dive maybe into some of them. Okay. So like you guys all already mentioned, there's a motherboard here. We have RAM, we have a hard disk, SSD, and CPU. These are the main components of that makes up a computer, right? As you can see, it says internal hardware, which means we usually don't see them in terms of a laptop or whatever, but the things that are external, those are the stuff that we usually see or interact with the computer using this external hardware. Okay, if we start from all of these here, the base thing, all your pictures and programs, whatnot, and music, the applications or software that you download, they are stored where? In a hard disk, right? It is called hard disk. Otherwise, in newer laptops and computers, we see SSDs, and you will see the difference between these two in terms of form factor, how they look in just a bit. Okay. Okay, so if we wrap up about this one, like we agreed, hard disk and SSDs are the main storage areas where we keep our programs, picture documents, and everything else. RAM is another memory, but it stands for random access memory. Okay. When you turn on a computer, when you turn off the computer, whatever you have in the RAM, all of them, they go away. So this is not a persistent storage. We call it persistent, meaning it doesn't save your data or pictures or whatever. All your data is being stored in here. Okay. Once the electricity is gone, RAM doesn't have any of your data. Okay, then we have CPU. CPU is basically, you've probably heard about this term a lot. CPU is basically the brain of the computer, which does all the calculations and all the instructions that you're asking it to do. This is like a brain of the computer then. We're good? And we will see those actual pictures in a little bit. Okay, so what is the motherboard? Motherboard is basically, you will see it in a little bit. It's just like some plate where you actually connect all of these devices and these devices as well in terms of keyboard and mouse. This is basically a hosting thing where you just, plug and play and whatever. So in terms of RAM, there's a slot where you can insert the RAM, put the CPU on top, and where you can attach your hard disks and SSD drives. We will see this in a little bit. Don't worry about that. This side is probably obvious. So monitor, it's where you actually see your data or documents or the Excel sheets or whatever you might be doing at the moment or any application. With the help of this mouse, you navigate and give some commands or do something like that, right? Everyone is probably aware of all of this stuff. Keyboard, that's where you enter, type in. Same thing with the mouse. It basically takes in some commands from you, or text, and it will deliver it to the computer, right? Or it could be like CPU, it could be some other stuff, but that's the main point. It's basically main point is taking instructions from you, text or whatever, and delivering it to the computer. Printer, you already know, you just print your documents or something. Speakers, I'm not gonna go into this as the name suggests. It's just whenever you're listening to music or whatever. Okay, so now let's actually see this actual images of these devices. So I earlier mentioned about the motherboard. So this is one of the examples of the actual motherboards that I found, I think, on Amazon.com. Yeah. This is from a brand Asus. It could be Asus. Okay, let me mute her. Okay. So we're gonna start from RAM. Earlier I mentioned that you have the slots on the motherboard where you can attach your RAMs, random access memory. We will talk about that in a little bit more in more detail, but these are the two slots that you have available on your motherboard, and you basically attach your RAM. And these are the types of the RAMs on the right-hand side, as you can see. So this slot is probably for this one. This one looks a little bit long, so it might be this one. Depending on the computer or laptop or your phone, RAM sizes, they are really small depending on the computer, okay? And the generation as well. There are a lot of RAM generation. I think right now we have LPDDR5, I believe, 5X or something like that. As you can see, it is saying it's a DDR4. So we have right now the latest, I think it's a DDR5 or something like that, okay? Basically, you take this part and you put it, basically you just push on top of this and you slide it into these slots. That's how you attach this your RAMs basically. So next one that we have you guys seen CPUs before?
No.
Okay, so even if you open up a laptop or anything, even your mobile devices, they all have this CPU, okay? This is how it looks like, and this is its spot here in the middle. So you basically, and these are the pins, as you can see from here, these yellow dots or whatever. These are the actual pins where you align them and you put it inside of here, okay? And on top, if you see, there are 4 holes here. On top of the CPU, we usually put the fan so that it doesn't overheat, okay? So that's a CPU. Do you guys have any questions about this? CPU, like I said, is the brain. This is the actual thing that does all the calculations or whatever you might be doing. It is basically executing some instructions and some code. Make sense? Also,
Yeah, I've got a question.
yes, go ahead.
What does that abbreviation CPU stand for?
So CPU that's a good question, actually. CPU stands for Central Processing Unit. Oh, actually it says in here, but it's too small. You see that? It says Central Processing Unit.
Oh, okay, good. Thanks.
Okay. So what else? In here we have also this, it says SATA port where you can attach the external hard drives, or it could be internal hard drive as well. I will show you the actual pictures of the hard drives. We have a lot of different versions of them. This slot here where it says M.2 interface, NVMe protocol, whatever. These are the new standards that we have in our laptops right now. This is your SSD drive, basically your new form of your hard drive where you keep your documents and all that stuff, right? Okay, and we have different manufacturers as well for CPUs and for all of these parts. It's not like one manufacturer who does all of this, okay? In this case, I think this looks like Intel to me. It could be AMD as well. We have Intel, AMD, and there are a lot more manufacturers actually when it comes to the mobile industry, mobile devices, mobile phones. They have Qualcomm that are producing CPUs and all that. Okay, so I think we've seen, and these are the ports on the motherboard where you connect your actual peripherals like the one we just saw, mouse, what else? Keyboards. This is for connecting the monitor. This is a little bit old one, VGA port. We probably still have them in use, but all the new monitors and all that stuff that are coming out on this age, the 2023, 2024, doesn't matter. They all have HDMI or display ports. So this is pretty old one actually, and this is where you connect your mouse actually. The peripheral, keyboard and mouse. Okay, this one actually says high definition multimedia interface. This is probably HDMI port that we just talked about. So you can either connect your desktop computer to HDMI if it has the port, or you can connect it to a VGA. Same idea with your televisions, right? Your TVs in the back, they have a lot of all these ports. They might even have the USB ports, HDMI ports. They might even have multiple of those where you can connect your to your TV. You actually can connect your PS4, PS5, PlayStation game boxes or whatever. You can connect your some other multimedia devices, and you can just basically with your remote controller, you can switch between those without you having to unplug your cable every time you want to use the other devices, right? So as much as you have all one of these, you can keep connecting every other device basically. Okay, and you will see about these ports in a little bit. And this one is basically for SSD, NVMe. This one here, this looks like it is the port for, there are a lot of stuff that you can probably connect to it, but mainly I think it's used for the GPU. If you wanted to play a great game or something, or if you are architecture or someone who does graphic intensive stuff, we have a separate unit which is called GPU. GPU is really great at graphics intensive tasks like architecture and your Photoshop and all those applications. Or if you want to play game, okay, you need to have this external graphics device. Otherwise, you may not be able to play at all, or you may get really slow performance from your computer because it doesn't depend on the CPU. It actually needs the GPU power to be able to show you, let's say, 60 hertz or 120 hertz games and all that stuff. Okay.
What about the video cards?
Yeah, GPU video cards.
Video cards. Right.
Yeah.
Like AMD or the NVIDIA, right?
Yeah, NVIDIA is one of the pioneers of this, frontiers. NVIDIA is pretty popular in this game. AMD has two. Intel, even all of these chips, they come with built-in graphics card, but they're not capable of doing a lot of stuff. It is capable for your regular tasks, you know, all that you see on the screen, right? Your buttons, your windows and all that, they have to be drawn by something. And that something is usually the, you know, the GPU video card. But the ones that come in built in into the CPU, they're not that much capable. They're really getting better each and every year. But like NVIDIA and all that stuff, they're really good at that kind of stuff. Like if you wanted to pay AAA games or something like that, you will probably need some NVIDIA graphics card.
And Mr. Sada, this for iOS goes to same motherboard, or this or only for Windows computers?
iOS, you said?
Like as Apple devices.
Yeah. So
Like
no, it used to be on laptops, on Apple devices. They were using Intel up until 2020. So after 2020, the Apple actually released their own silicon. When we say silicon, it also means CPU, okay? They released their actual, you know, CPUs, which they call Apple M1, M2, M3 families, right? But with their silicon, things are really different and they're really efficient. It's a different architecture. It was built on ARM architecture. It's a totally different architecture. These are what is known as x86 architectures, okay? And if you paid attention, if you can see, the CPU lives here, your RAM is here, and your SSD is here, right? Your where your data lives, right? So data travels from here to RAM, which we will talk in a little bit. So it makes a little bit slow because it has to travel between all of this. With Apple Silicon, actually, they have something called unified memory and all that stuff. All these things, memory and not the hard drive, but the memory and the other processing units, they basically come prepackaged on a CPU, which makes it really fast and really efficient because the data doesn't have to travel that much distance. So if you look at here, you might think that, oh, you know what? It's not a big deal. It's not traveling that much. It's not like 1 kilometer or something like that, 1 mile distance. But when it comes to this kind of stuff, it really matters how, you know, how much the electrons or data has to travel. So if you have memory as much as close to your CPU, you can get really good performance on those. And I think it's one of the main points of Apple's success today. Their computers are really efficient. That's why you can get a lot of battery as well. Their laptops last for, I don't know, 10 hours, 15 hours or whatever. Okay. It's one of those reasons, but underlying architecture is totally different than this. These are really too detailed topics. I don't want to go into it much, but yeah. Sasha, thank you. This motherboard is actually for the desktop computers. You guys remember desktop computers that you put next to your, you know, monitor or something? That's a big thing. Although nowadays we have really small desktop computers as well. But these are coming from that. It's not for laptops or something like that. Make sense?
That's for processor, right?
Which one? This mother?
Yeah. Processor is like a huge separate port standing by
Yeah, this one is really big ones. I think I don't exactly remember, but it could be 3.5 millimeter or something like that. I don't 35 millimeter or something like that. The width and height. There are different sizes of these. So the ones that you get on actual like laptops, they're really tiny. But again, same idea on laptops as well. Laptops have fans as well, except the, you know, the Apple's MacBook Airs, they don't have fans. But in general, this whole idea, this thing, like a motherboard having SSD, hard drive, they all have same thing, same components, basically. And this one in here, as you can see, this is a battery, actually. This is called the CMOS battery, which keeps, even if when you turn off your computer, This thing is responsible to keeping the clock on your computer up to date. So it's whenever you turn back on your computer, you actually don't update your clock, right? It's already the time is usually correct, right? Okay, so let's see what else we have. And these are the hard drives, the storage devices that we have or we had before. This is the one that I was talking, the new form factor. It was on the right-hand side in here. The slot. This is the slot for that NVMe drive. This one. And you guys are mostly probably familiar with this one, where we've had this for ages, I think 20, 30 years, I believe. Basically, this one is the update, the new version of this. Okay, this thing here is the updated version of this. In terms of the speed, this thing here, we already said the SSD, and as you can see, these would be hard drives, HDD. And it has a magnetic drive in the middle. It has to turn and finding the data and all that stuff. It's really slow on this one compared to this. There's nothing mechanical in here. There's nothing, turning inside of this SSDs or this one compared to this here. That's why these are much more faster compared to this hard drives with the magnetic drive inside. Does that make sense, guys? Any questions so far? Are you guys bored or? I'm
No.
not.
All good.
All good. Yeah, go ahead. Someone had a question? Okay, assuming no. Okay, nowadays, like I said, on your laptops, mostly you will see this, okay? Because they are really fast. Today's computers, they really, boot up, they start up really fast. Thanks to all of this technology that is coming out. You might see different form factors of this. It could be like this long, or it could be like a midway in here. But they all do the same thing. They're all SSDs, depending on how much space that you have in your computer. Manufacturers like the brands, Apple, they will choose shorter one to save some space. I think on Apple's new laptops or the desktops, I think they use the shorter one here, like this. But that's not important. The idea is here is they do the same thing. They store your programs, they store your documents, pictures, and all that. Okay, so now we talked about the computers in general. When I said when we went over all of this here, right? So this applies mostly to all the devices that you are using today to, for whatever, watching movie or whatever, it doesn't matter. Even in your phone, even in your on your smartwatches, they have something similar inside of them. Okay, they're really tiny because they don't need that much stuff in terms of your what do you call smartwatch, but they still have all that technologies inside. You still have on your smartwatch, instead of a monitor, keyboard, mouse, you have a touch input, right? Which takes your inputs and tells your smartwatch to do something, because you don't have all of this peripherals. But the idea is the same. Okay. So what is the difference between then server and let's say desktop or computer or laptop? It doesn't matter. Anyone wants to give it a try? Any ideas?
It's like a main computer.
Yeah, so you probably heard about the terms the server, right? Have you guys heard? Maybe I should ask that.
Yeah.
Okay, so what do you guys think the difference is?
So the server is something that store data, and a desktop where you put this data.
Okay.
Probably server, it's more powerful, more capable, with more RAM and with more memory. and more powerful CPU just to produce more power to do more processes in same time.
Okay.
And transactions.
Mm-hmm.
Can,
Yeah,
can be resourced to other computers as well.
Correct. Yeah, but those all three are, I think you guys are, those are really good points, and they are actually correct. But anyone else? Any other ideas?
Like administration, the server.
Server is for administration. Okay, good. Can you expand on that? So what exactly do you mean?
Well, the rest of the computers should listen to whatever the server put in there as a rules
Mm-hmm.
to
Okay,
determine how
nice.
they're gonna work. Because the server can work with multiple desktop computers, right?
Yeah.
Because it just depends on how for how many like account or the people who gonna work the computer.
And also, I think server they have probably Linux only because it's more easy to operate and delegate to other computers processes.
Okay, nice. Yeah, I like all those answers. And Bakhtigul says storage for data on internet. Those are all good points. So in terms of if we just talk about the hardware side, so can we just say that the server and the computer, they're at this basically at the basic level they are the same thing? Can we say that? Nope. Bakhtigul says nope. Okay.
Server looks like unlimited the options has instead comparing the computer or the desktop. They have limited.
They have limited what? I'm sorry.
Have a limited controlling the editing or setting instead of the server. I mean, the server can control the computer, but the computer cannot control the server, right?
Can control. Well, server can, depending on what server we're talking about. Right now, we're talking about only from the hardware perspective, right?
May I say?
Yeah, but if you talk about from the perspective of managing the computers, yes, server can control the computers in the enterprise, in the company, given that you have the software installed on your laptops or computers. That's a good one too. Please go ahead. Who wants to?
Server has more capability just to add more hard drives and operate them. Personal computers, they have probably only like 4, or you just to get some extension just to add some more hard drives there.
Yeah, nice. Yeah, those are all good points actually.
But the logic of it is the same, right?
Yes, so that's what that's one of my questions was. So can we say computer and server is basically the same thing? They're both computers. Can we say that?
Yes.
Okay. We can say that, but like all of you guys mentioned, there are these pros and cons to each of them, right? One of you guys already mentioned that they can handle a lot of the storage and all that stuff, right? So let's see. So this is I just got this picture from, I don't know, from Dell's website or something. So this is what the server actually looks like, right? And you have already mentioned that it has a capability of adding more storage. So usually these things here that you see, how many of those? We have 12, right? We have 12 bays here, slots where you can slide in the hard drive, and it could be, each one of these could be 2 terabyte or 4 terabyte. So if it was a 4 terabyte, we're talking about how many terabytes here? 4 times 12. We're talking about 48 terabytes, right? Okay. So this is really hard to achieve with the, let's say, laptops, okay, in today's standards. And as you can see, it has much more cooling system because it's handling a lot of traffic. You guys have already mentioned all these points, basically. And these things are actually heavy. So I had the chance to work with these hardware, like closely. We were installing and we were managing servers and all that stuff. So I'm lucky to be able to, to get a chance to work with these closely. So I can tell you that these things are really heavy, actually. So we used to, grab them two people, like to be able to even lift this thing. Okay. It doesn't have to be this. There are some servers that are really slim, like this, the first slot. Depending on the, like you guys already mentioned, depending on the power, depending on how many hard drives it can handle, the size and everything will be different. And as you can see here, it has already like 3 huge fans here, right? To cool it down, to cool all these components that you see. But at the basic level, they're the same. So like a laptop or your desktop computers, they don't have attached anything by default, any mouse or let's say keyboard or monitor. Only we attach those things when we wanted to manage it, right? They have these in the back here, they have lots of those ports where we can attach actual monitor and keyboard if we wanted to manage it by if we are just sitting next to it. But today, what we usually do is we remotely log into these systems, right? Into your servers with remotely, but using some other tools. It could be a remote desktop tool or it could be SSH. You remotely log into this and you manage it from your own laptop. You don't have to be next to this server. Okay, what other capabilities? You guys, like I said, you guys have done a great job. You already mentioned it.
Probably another one main difference, because you say we can join like from another PC. All servers has already like pre-installed some not programs, but probably maybe in motherboard some like algorithm, which one gives them chance to reboot and continue working without any like physical resetting that servers.
Exactly. Yeah. You can do that depending on what do you install or what do you have on your servers. That's a good point too. What is the other good point? The difference between the regular computers that we use or we have at home and these servers. If you look at this picture on the right hand side here, you see how it has 4 power plugs. So what happens? So when you're using your laptop, if you run out the battery, what happens? It just turns off, right? Turns off, no big deal. You can just find your plug, attach it to the wall and whatever. You can just turn back it on. But with these servers, it's a problem. If let's say for some reason let's say it's power gone or something happened here, if it had only one power plug, it is a problem because let's say people are shopping online and your servers are down. Your website can't receive any orders, right, from your customers. That means you are losing actually money from a business perspective. Or if you are, ordering some food or whatever, doesn't matter. That's why these devices, servers, they have some redundancy systems. Do you guys understand when I say redundant?
No.
Okay, when I say redundancy systems, that means they have something extra to be able to mitigate those situations where you can get your maybe there's something faulty happens in here and you are out of electricity. So it's nothing is powering it, right? So if we take a look at this picture, it has 4 redundant power plugs just in case even if one of them or 3 of them they break or something happens, it will still operate because it has the 4th plug. That's what we mean redundancy. They might even have, I've seen some that they have 2 CPUs. They have extra cooling systems just in case 1 or 2 of them they go out, so that it doesn't get overheated and it doesn't blow up in terms of it's not gonna stop or turn off. That's what we mean by redundancy. Does that make sense? Same thing happens actually when we talk about all of these components here. We actually missed it to mention the network cards. How do we today when we're using our, the internet or something like that, we need for that another component, which is called NIC, Network Interface Cards. Using those cards, that's how we are able to communicate over the internet, okay? So if we come back now to the servers, when I say redundancy systems, right? They might have 2 or 3 of those network cards. Just in case something happens to these are electronic stuff, it can happen, which is, if you think about it, it's really rare these days because we have great testing environments and all that. It's really hard to find situations where the hardware fault or something happens. It could still happen, but it's still really rare compared to 23 or 30 years ago. So if we were to look at the back of this server, it will have, like I said, 2 or 3 maybe ports where we can plug in our internet cable in case 1 or 2 of them they go out. Does that make sense, guys? Did you understand what the redundancy is?
Yes. Thank
Why
you.
we need it?
Yes.
Okay. At the basic level, though, they're all computers. They have the same thing. They have the motherboard. They have the hard drive, fans, and all that stuff. They're the same thing, okay? I just wanted to make clear because there are sometimes that people can't. They think server is something superficial or it is something, it's not a computer or something like that. But at the basic level, it's still a computer. Okay, and this is from the left side, from the left bottom, as you can see, this is a Google's data center. I got it from Google's website. So these are where all these servers are being kept. Another pros and cons, let's say pros, all these data centers, they have a really sophisticated buildings actually. Even in when I worked back in the time, even our data center, it was pretty small compared to this one, but we would have redundant systems in terms of the AC so that they cool it down all the time. We have like 2 or 3 of AC working all the time, just in case if one fails, the others are still cooling. Also, what else did we have? We had elevated floors, just in case if there's a water flood, right? So it cannot reach the servers actually. So it would be elevated a little bit than your regular ground. And underneath it would be basically like a empty, right? Also, what else do you have? I'm pretty sure they have way better systems in here. They probably also have sensors as well, which can sense, let's say, earthquakes, water flood, or when the electricity goes really high or down. Another thing, I wanted to ask you guys, what else you can actually find in here? Since we were talking about the redundant systems, what else do we need here? Any guesses?
Cooling.
Okay, yeah, cooling. We just said the cooling. We probably have a lot of extra coolings just in case if some fails. That's a good one. What
Maybe-
else?
Maybe something with electricity?
That's a great point. That's what we're looking for.
Yeah,
What-
probably they have independence lines or something.
They might have extra lines. What else?
Extra generator.
Generators.
Not
Generators as well, right? Just in case the electricity goes out, they might have a maybe gasoline generator outside somewhere, which can, still provide some electricity. At home, I don't remember what is the English name for those. If you guys remember back in the day, it was really popular, where we had this kind of device. Even if, let's say, electricity cuts, you would still have 30 minutes or something like that, which is powering your computer so that you can save your work or whatever. Do you guys remember? Like a power bank, yeah.
Yeah, that was, yeah.
Okay, so now imagine what kind of stuff they have here. It's probably, I can't even imagine. But definitely some sort of a generator and all that. Okay? And if you think about it, this is beautiful. This is the art of engineering, I think. You see how everything is organized and really clean? So I would like to point out from our last session, do you guys remember when we were talking about a lot of data, what exabyte looked like compared to Earth, if Earth was a petabyte, let's say. You guys remember all that stuff?
Yes.
And we said there must be some people that are hard at work to make it possible, right? So
Mhm.
this is one of those things that you need to see, and we would like to see. I personally would like you to see it, so that we can appreciate and how much actually work is being done in the background. So it's not like something that couple hundred people can pull it off, all these things. That's why we have
Видела мои наушники? Не видела, доча?
That's why we have a lot of these different fields, okay, which make it possible.
So can I ask you a question? When
Yes.
there's an issue
Okay.
or some of the servers are going down or something, so who works with that? Is there any like a I don't know, field or the name for that profession? How
Yeah.
they call
Okay, so that would be still a part of the DevOps, okay? If you guys remember about the DevOps we talked, they have different fields. So network engineers, system engineers would be the people who will be fixing these. And
Oh,
and if you
I'm sorry, one more question. I'm sorry
Yes.
about that. But like I heard about that DevOps, they having a thing like being on call. So on call, it means like what? You're making sure that the service is not going down?
Yeah,
Or-
just in case if the server goes down or something happens, they're gonna reach out to you so that you can bring it back or do something about it to be able to troubleshoot and hopefully to find a solution. So you would be on call just in case something happens. Usually, if you are working for, let's say, some close
Это накладывай себе.
or something like that, you would be, when customers are shopping, there are millions of customers are doing something. You want to make sure that you don't lose, customers while the peak
Is it
hours.
remotely? Do you fix the problem remotely or is like you physically go there?
No. In today's world, you don't go physically there. It's usually remote, and we
Oh.
will actually talk about that in a little bit. So actually, I can just mention it. So another topic, another term that I mentioned, Betul and my colleagues, they will be talking about. We also talked about. Have you guys heard about the term cloud?
Yes.
Okay, so who's actually answering the question? I'm not sure. I can't see. Dinara?
Yes, Dinaro.
Okay.
I see
Dinaro.
there are Dinaros, it's different than that.
Yeah, okay. The question to you. So where do you think actually our data or pictures are being stored when we say I just saved my pictures to Google Drive or iCloud?
Probably in the server.
Where is the server?
There.
So these would be the clouds that we call it, we give them some fancy name, but this is the cloud, right?
Exactly where we save our information. Yeah.
Yes, it's somewhere in Apple's data center, somewhere stored your picture. Whenever
Yes.
you need it, it will bring it to you.
So basically, let's say when we're paying our, I don't know, the iCloud payment monthly. So basically we're paying for that space.
Yes, if you need more than 15 gigabytes, I think the base
Yeah,
store, maybe
like
5
whatever.
gigabytes. Yeah, if you need more, you have to pay, right?
Yeah.
Yeah.
So that's what we're paying for this?
Yes.
Okay.
So they maintain. And the other thing is, when it comes to data centers like this, when you save, usually there's a, let's say, little chance you to losing your data, right? Once you
Yes.
save to iCloud or whatever, you can probably reach those pictures or documents maybe a year later or 2 years later, as long as you pay your bills or whatever. What actually happens, even Apple and whoever is managing all of this, they are keeping the redundant copies of your data, just in case if that hard drive or whatever they are keeping your data, if that goes, if that component fails, so they don't lose it. Okay. So now if you think about from this perspective, you think like, you know what, it's actually worth paying, right? Because a lot of stuff has had to be done to guarantee that you're not going to lose your data. It's not an easy task, actually.
Mm-hmm.
Okay, so everyone, do we understand when we say cloud? I want to make sure that it's not something in the cloud or whatever. This is where your stuff are being kept. Okay. Nice. Any questions about this?
Yeah, Serdar, I've got a question.
Yeah.
So as far as I know, DevOps engineers deploy data on the site and on the cloud, right? It's two types. That's what I heard. I'm not sure.
So when we say DevOps, DevOps is not like a title. They have a fancy terms. DevOps is a mentality, mindset, whatever. DevOps is basically like saying computer science, right? It's not like the title, but computer scientist, software engineer is a title, is the person who actually does something. DevOps is the same thing. I think they love to say DevOps is a mindset, it's a culture, whatever. But in the basic terms, it's same thing as you when you say accountant, you refer to a person, right? But when you say accounting, it's a field of accounting or whatever. So same idea. Depending on back to your question, depending on what the title is, it will depend where he's doing what job, and depending on the company as well. So if you guys have heard about so we've already covered the term cloud. Now, did you guys hear about the Google Cloud, AWS, Microsoft Azure? Have you guys heard of?
Yes.
Yeah.
Okay, for those of you who haven't heard, I'm just gonna make it easy. So now, if you're a smaller company or if you don't want to hire people who will be managing all the stuff in here, in this data centers, and once in a while, let's say in 2 or 3 years, you want to upgrade your hardware as well, right? Because there are new CPUs are coming out, new RAMs available, much cheaper, maybe much powerful. So for all of that, you have to maintain group of people who does that for you. Networking people, database people, and all that. If you don't want to do that, if you think you will be better off just renting it from somewhere who provides these services, that's where you search for Google Cloud, AWS, or Microsoft Azure. Those three companies, they provide these cloud services. Do you guys understand when I say cloud services?
Yes.
Any guesses? Okay. What do you guys think what kind of services you think we are getting from these cloud providers?
Keeping your data there.
Keeping your data, okay. What about in terms of hardware?
Probably having access to it, adding the information.
Okay. That's good. Yeah, that's good point. Another thing is what you are actually doing, you're basically renting the servers.
We can use power of those servers,
Yes.
services and servers.
Yes, you're basically renting their hardware. You are using their, this hardware, their servers, and they have to maintain all of this stuff. You don't care about what happens in here. They take care of that, and that's why you pay the money, right? So when you are working with cloud providers, did you guys understand about these cloud providers and how you are renting these hardwares?
It's
Anyone?
like a Google Drive, basically, right? That's
Yeah,
what it is.
Google.
Kind of.
Yeah, so you see that Google Drive is basically some application living somewhere in here, right? It's a software as a service. It's giving you some service, and you're uploading your pictures or doing whatever, but they're running on these devices here. But if you are some company, let's say you are a bank or you are some financial, some other place, or you are insurance company, and maybe you don't need all these engineers or you don't want to keep, renting this huge place to be able to, keep your servers and whatever. Maybe it doesn't make sense. For some businesses, it really doesn't make sense to have this huge place. So that's why you go to places like Google, Amazon, or Microsoft to actually rent the stuff. Okay? They basically give you for rent these devices where you can install your software or your website and you can use it. As long as you use it, you pay the money. Does that make sense?
Yes.
Okay. Any other questions about this?
Yes, Serdar, back to my question. I still didn't get it. What's the difference between deploying on the site and deploying on the cloud?
Deploying on the site. So I don't have a lot of context what you mean by deploying on the site. By deploying on the site, what I'm understanding is you are standing to this next to the servers and you are attaching the cable and you are installing and doing whatever. Oh, I see. Okay. No. I think what you mean is you've probably heard the term deploying on-prem as opposed to deploying on the cloud.
On premises, yeah.
Yes,
and on
okay.
the cloud.
Yeah. Okay, so what on-prem means is it's coming to the same thing. Some companies, big companies, they actually have their data centers. Like in my case, the company that I work for, we have our own premises, meaning we have our own site or data centers like this. We actually manage it ourselves, okay? So that's why we say on-prem versus cloud. But now, even my company is switching to Google Cloud.
It's
As you
cheaper.
said before, if the company is small, it doesn't make sense to to rent these kind of big places to have their own services, right? In that
Yes.
case, like deploy it on the servers,
Yeah.
on
Even some big companies, they are switching to cloud, like a Netflix and all those companies. I think they're on AWS, Amazon. I don't think they have their own data centers like this, as far as I know. But for small companies, it really doesn't make sense because you have to rent a place, like actual physical location. You have to do all these cabling and all that stuff, right? These are not cheap stuff. Does that answer your question?
Okay.
Yes, thank you.
Yeah. Okay. So now that we talked about a lot of hardware and all that stuff, we need something that that makes it usable, right? If we don't have something that makes it usable, what is this hardware? It's just a bunch of metal or plastic or something like that, right? It's not usable. Do we agree, everyone?
Yes.
Okay, what do you think we need to make it usable?
Logic of using it.
Okay.
So
What
the-
else?
To program to connect them.
Okay, that's good. Anything else? So Shahruz, what do you mean by plugins? He says plugins. Software, right? Dile says software. That's a good point, Shahruz. Software, yep. We need software, right? That runs on top of them. So it's actually usable piece of hardware. Otherwise, without the hardware, without the software, it's just a bunch of metal or whatever. Okay, so for that, now we're switching to a software part. All of this thing that you're seeing on the screen, you might be familiar. You've probably seen all these icons millions of times. Can we say all of these are software?
Yes.
Okay, these are the things that actually make the computer or your mobile device usable, right? If you didn't have all of this, it will be really hard to do anything, actually, especially on the mobile phone. Nowadays, we have all these banking applications and email applications, your Google Drive and all that. PayPal here. And one of the popular ones is, I think, Google Maps. Probably everyone is using it. Okay. So when it comes to software, now that we have hardware, we need the software, but are you guys familiar with the operating systems?
Yes.
One? Because when you have your mobile device or a laptop, you can't just install your application on top of it, right? You actually have the operating system part. That's where you actually install your applications, correct? And these are the I think the popular operating systems today. This one is probably most of you are familiar with, Windows, Microsoft. We've been using it since, I don't know, 2000 or maybe 1999 or something like that. Everyone is familiar with the Windows operating system.
Yes.
The latest one is Windows 11. And Apple's operating system it's called Mac OS. And the one you are using on your actually iPhones, it's iOS. On your smartwatch, it is what is it? Smartwatch OS or something like that. But then we have the really popular one, Linux operating system. And in all those Android phones, Samsung phones, Xiaomi phones, Motorola, all of them, they have Android operating system, which is developed by Google. This one I'm not familiar with. It's probably Linux-based operating system as well. But before we go on to discussing more about the operating system, do you guys have any questions about these?
What is the Linux for?
Oh, that's what we will be concentrating on in a little bit.
Oh,
It's another operating system.
That's how all operating systems, I mean, the other programs, I mean, there's more.
No, there are a lot of them.
A lot of them. That's
But
amazing.
These are the major ones, but all the operating systems that you might have heard of, they're all based on the Linux. Maybe you might have heard Ubuntu, Pop OS, Red Hat, Fedora. They're all Linux-based. I can't think of any other operating system that is popular nowadays. Can you guys name any, if you have any in mind?
not really.
Not really, right? So you're probably who is using what? Anyone wants to share their info?
Mine
you
is in iOS.
Mac OS.
Mac OS, Windows as well.
Okay, Bakhtigul says iOS. Okay, on your laptops, anyone using Windows?
Yeah, I use Windows.
Nice. Okay. Okay. So why we're talking about all of these operating systems? Operating system, you need to have this installed on your hardware to be able to install then other applications that make your life easy. For word processing, or if you wanted to write some documents or whatever, you use what? You use Microsoft Documents, or you just go to Google Docs or something like that, right? What basically if you were to generalize them, those programs called word processing programs, Microsoft Word or text editor or something like that. Doesn't matter. Okay. So now we have these hardwares. Now we need the software on top. And as you can see from this diagram here, this is your hardware. This is where the operating system lives on top of this, where you install on the hardware. Then, depending on your operating system, that's where you install applications. So if you guys remember from Windows, whenever you download some application from internet, they all end with .exe or .msi, right? Those are the extensions that Microsoft operating system Windows that understands.
Yes.
And Mac OS, if you download something other than your, Apple's App Store. Let me mute it. If you download something for Apple, its extension might be different. It's probably different. It's I forgot I think DMG or something like that extension. So now, and here's another picture just in case if you didn't fully get it. You have all these devices, hardware or whatever, without any software or operating system. These are basically useless. So you install operating system, and then you have application. all the applications that you install, web, Chrome browser, or your mobile devices, doesn't matter. Let me see that. Okay. So now, why did we mention Linux here, and what is Linux? Linux is open source operating system, okay? We will, in our DevOps bootcamp, we go into a lot of detail of the Linux operating system. In reality, if I wanted to use the correct term, Linux actually is the kernel, but I'm not going to go into detail here what the kernel is or whatever. Let's just agree upon that all these things that you see here, Debian, GNU, or Ubuntu, they're all Linux-based operating system. It's the same thing. It's a operating system like Mac OS or your Windows. Okay, so why it's popular in the developer environment or in the case of servers? Is anyone familiar with Linux, or do you guys have any guesses? Maybe you have heard something that you want to share. Anything like that?
No.
Linux has more options to create and write in the program instead of the iOS and the Windows, which has the limited tools to coding or using the specific program for coding.
Yep, those are good point. And Shahruz says, with Linux, you can create your own OS. That is true. So Linux, what is it?
Is that true that the Linux can create your own operating system?
With Linux?
Yeah.
Yes.
Linux can create their own operating system, which is the Windows cannot.
Well, yes. So yes, in terms of because why? So Linux is a free and open source operating system. What does that mean? When we say free software, it doesn't mean the financial wise, okay? So when we say free operating system, we mean by that free as in a free speech, okay? Not the financial part. And it's an open source operating system, which means you have access to its code, actual source code, where you can open it up and read how people wrote this operating system. And if you just happen to don't like something, you can always modify, you put in, if you don't, some parts, you can remove it, and you can build your own operating system. Does that make sense, guys? Do you guys understand what I'm saying? With all of these operating systems, well, there's an open source version of Android as well, but Mac OS is a proprietary operating system for Apple, and it's not open source. So you cannot just take its source code, find it, and try to understand. You will not be able to create some other operating system from Mac OSs. It's proprietary, it's closed source. Same thing with the Windows. But like I said, Linux, open source and free software, okay? Did you guys understand what free means?
Yes.
Okay, free as in free speech, okay? Has nothing to do with the money.
But
Open source, what is it?
How does the Linux works? Do you download like an app or it works on a website or?
No, it's the same way as you download the Windows installer. You can just download the Linux installer. These days, it's really easy. Back in when I started, I think 2010, it was really hard to install on the machine. But these days, it's the same as a Windows installation. You just click next, and you select your username and password. You're done. It's installed on your laptop.
Okay.
Why they use Linux? Like I said, it's open source. People take a look into the source code. They can, if they want, they can improve. If they see some issue in the code, they can, suggest the fix. And you will probably know whenever you go to DevOps bootcamp or some other bootcamps, depending on what you decide. But with Windows and Mac OS, you can't change it, right? And also, I would highly suggest using something else. If you're using Mac OS, it's still better than Windows because Windows has a lot of tracking software in the background. It has that Cortana where you cannot even, I think, turn it off. So you have no control over this one. And by default, if they want, manufacturers, they install a lot of you know, the applications. It could be Amazon or it could be some eBay application. Even if you don't want, when you are buying a new Windows, they install a bunch of crap on your machine. Then you have to uninstall if they allow you to uninstall. Okay, so from the perspective of privacy, if you want privacy, if you care about that, Windows is not a good option. Okay, Mac OS is way better when it comes to the privacy compared to Windows. Like I said, on Linux, you can do whatever you want. You want to remove your microphone driver or whatever, you're free to do that. You can build your own operating system. That's why now we are coming back to why Linux is popular on servers. So if we switch to this picture here. So if you were to guess, if I were to ask you a question, if I were to install Windows here or Mac OS, you can do it. They don't just Mac OS is solely on Mac Apple computers. Okay, so the only options that you have is Microsoft, Windows, or Linux. So if you were to guess, what we do actually not need on the servers compared to our laptops? What features that we have on laptops and desktop computers that we use, and it doesn't make sense to have them in here on servers and all these places in data centers? Any guesses?
Applications.
Applications, okay, that's a good one too. Yep. The personal applications that your Excel or whatever, it doesn't make sense to install them here, right? Maybe Chrome browser, correct? That's what you mean, right? By applications?
Yes.
Okay. What else? Anyone?
Maybe other physical devices like monitors or whatever.
Okay, that's good. If you go from physical, what else we have on laptops and
keyboard, mouse.
Okay.
Yeah.
What about Bluetooth? What about camera?
Well, we don't need it as well.
We don't need the Bluetooth or cameras, right?
It's hardware connected by like cables, I think.
Yeah, these are connected with cables. And you
Touch
don't need
panels or whatever.
Exactly, yep. On the racks and stuff. You don't need all of that stuff, right? You don't need
Correct.
cameras, you don't need Bluetooth drivers, you don't need some, I don't know, if you are not doing any graphics intensive stuff here, you don't need a graphics card, right? So why, if you don't need those, why would you have all of that stuff? Actually, before we go into that, what else do we not need here on from the software perspective? If we're connecting to these devices remotely, what do we not need? Do we need a desktop environment? Do you guys understand when I say desktop environment?
No.
Delia says we don't need OS. Is that true?
We need actually some OS operation system.
Exactly, we need OS. Without OS, it's just a metal. It has no use for us. But do we need this desktop environment? Do you guys understand when I say desktop environment? Desktop environment basically means, you see how I'm navigating with my mouse, right? Like this. I'm clicking here, I'm clicking on this window. Do I need all of this?
No.
Probably you're talking we need only like just to type some programs, codes.
Yeah, so you see, this is part of the file explorer. All these windows, all this stuff that you're seeing, right? You can click here and there and all that stuff. You don't need all of this stuff, right? On these, let me bring it back now. On these supercomputers or the servers. That's why when you're using Linux, you can opt in, opt out, meaning you can remove all those unnecessary heavy or all these applications that you're not going to use it. That's why in our DevOps journey, bootcamp, or any other field, we actually teach people. In any other bootcamp, they probably teaching you how to navigate inside of the Linux without all of this, because when you are connecting to this device remotely, you don't have a mouse or anything like that. All you have is this window. Okay, let me show you. Do you guys see this window?
Terminal.
Terminal. This is so all you do, you click, you copy something from here to another place. All of that you do by these commands. Maybe copy, maybe move, and all that stuff. Okay. That's why we don't want to. Why do we not need all of that application, the Bluetooth or desktop environment? We don't want to waste our resource. We don't want to waste our RAM or the hard drive trying to have a desktop environment where we can click, and we're not even using it. Does that make sense? Or it didn't?
Does it mean that Linux is kind of dominates on the server market?
It definitely dominates. I think it's a 98 or 97%, I believe, of the servers in the whole world, they're all running on Linux.
Got it. Thanks.
Enterprises are running on the Red Hat Linux. Okay, it's one modified version of Linux. It's called Red Hat. We have Ubuntu and other places and other operating systems like Ubuntu and Red Hat. On desktop, obviously, Windows is probably leading, then Mac OS probably, and then it could be Linux. But on if I show you a desktop environment, it doesn't look much different than your actual operating system. Let me show you Ubuntu operating system. This is a Linux-based operating system, and as you can see, okay, it's the desktop that you see. You see, it's the same thing. You have all the applications. You click, you do whatever you want, as usual as like Windows or Mac OS. We can go from images. Does it look different? Besides the themes, it's the same stuff, right? You have all these buttons where you can click, close. You have your Wi-Fi and all that indicators up top here. Okay, same thing. It's really popular. One of the most popular distributions of Linux. You might hear the terms like distribution or flavor. That means it's just a different version of Linux. So in this case, it's Ubuntu. And as you can see, you can also install 2 operating systems on your laptop or desktop. Side by side, you can do all of this stuff. So on the left side, this is your usual Windows 10. Right side, Ubuntu, which is Linux-based. Any questions, guys, before we move on? Okay, we still need to cover a lot, actually. Let me move a little bit faster. So I'm assuming you understood all of this, right? Software, hardware, why do you need it? Correct? Any questions regarding these? So now that we need, okay, I'm assuming everyone got it. Now that we know we have the hardware, we have the operating system, what else do we need? Or how can we create these operating systems or applications that you are, using daily? Chrome browser, your Instagram, or whatever you have. What do we need for that? We need a programming language so that we can write some code to explain to a computer so that, it translates and does basically what you requested, right? On your Chrome browser or your word processor, Microsoft Excel, Word, doesn't matter. using programming languages, we basically create programs, software. And there are actually, I think the last time when I checked, I think there are like almost close to 5,000 or 4,000 programming languages in the world. Obviously, they're not used, most of them. Probably most of them died out, or some of them never got traction. Nobody used it. But today I just got this most popular programming language by 2023. As you can see, Python is 30%. It's leading. In the second place, it's Java and JavaScript. So using these programming languages, any of these, you can create programs, software, right? Swift and Objective-C, these are the languages that are used to create macOS applications or your iPhone applications, okay? Other than that, I don't think it's being used. That's why you see it has really small percentage because it's mainly for those devices. Do you guys remember, or do you guys know what JavaScript is used mainly? Anyone?
UI.
Websites.
Yes, it's mostly for website, right? Front end. Do you guys still remember? We talked about the front end, building websites. Buff good? Yeah, front end. Good.
Back and forth.
Okay, so this language is popular on that front, okay? If you wanted to become a web developer or some front-end developer, JavaScript is inevitable. So you have to know this one. Python, I think I might have in the next slide. Python is being used by DevOps engineers. When I say DevOps engineers, think of it, network engineers or all this, stuff in the DevOps, okay? It's being used in DevOps, data science, data and analytics, web development. What else? Machine learning. You guys familiar with machine learning as well? It's what else we have? I think
Data science.
Yeah, data science. I already said that. Data science, data analytics, data analyst, basically. Python is really popular in all of those fields. Okay. So when it comes to Java, Java is, I think, most popular in financial markets, financial industries. It could be insurance companies, it could be banking industry, it could be anything related with money and all that stuff. That's where it's popularity. So if you are becoming SDET or QA, like we talked, can anyone explain the difference between SDET and QA? We talked about on Monday. Anyone wants to give it a try? Do you guys still remember?
Manual and optimization.
Yeah.
Yes, the QA was the manual mostly, right? And
Yeah.
SDET for the optimization.
Great. So QA will be usually not going to be dealing with writing some code. They're usually, putting input, they're inputting some data and clicking here and there and trying and making sure. Basically, they're given some, let's say, some object or something, and they're trying to break it, okay? They're just guessing, and it's not like guessing, but they usually know, experienced QA probably know what type of data they can input that could potentially break the software. So that's what they do. But SDET is expected to know Java because they have to write some Java code, a lot of automation actually, so that you don't have to click and test every feature all the time. Okay. Also, well, it's like I said, it's really popular in the financial market. It's one of the hardest, I think, compared to Python. It's really hard. I think it's much harder than the Python, and I will show you the couple of code snippets in a little bit. JavaScript, it's unavoidable when it comes to web development. You have to understand, at least know something about this one, okay? C# is popular in the Windows world, usually. Using C# and other tools, you can build applications for your Windows environment. All these applications that you see, they probably were written with C#. So guys, when I'm saying all of this stuff, this doesn't mean I cannot build a website using C#. You can still use Java or any other of these languages and build a website. PHP is solely used for building websites usually. Okay. Do you have any questions about these?
I mean, so the C# is the same as a C++, or the C++ different?
No, those are different. So C# is this one is basically invented by Microsoft. It's a Microsoft programming language. And C++, if you mean C++, it's completely different. It's more popular in the systems development or game development.
And
Right?
the program languages works as a main tool for software engineers, right?
Yes. And also any other field, actually, data science or data analysts, they use Python, or there's another programming language, I think it's called R. Basically R. This one. There you go. These are being used by those as well. To from DevOps perspective, they're using Python to automate something, right? But data analysts, data scientists, or machine learning engineers, they're using Python, actually writing some code they need to analyze data, to clean the data, to prepare the data to be able to train your artificial intelligence, your machine, basically. Because you need to feed your data. I mean, that's how actually machine learning and artificial intelligence are being done, right? They have a bunch of data, they prepare it, and they just feed it to the program to train their models. That's how you get ChatGPT and all that stuff today. Okay.
And program the operatings as such as operating systems, you can write by this program languages, or for those users specifically some sort of programming languages.
To write operating system?
Right.
Yeah, so there are some languages that are really good. So you probably all know the term right tool for the right job, right? Or right tool for the job, or something like that. So these are not like Python, Java, JavaScript. They're not ideal to write your own operating system. For that, usually it's used C, C++, or there's another language which is being most languages, I think it's called Rust. But these languages are really hard, so it's not recommended for beginners, at least. And also, I think I've tried. If you type in, what is the beginner-friendly programming language?
Civil CSS or something?
Usually it comes up saying Python. The most beginner-friendly. The most beginner-friendly programming language. I think I've already somewhere I've seen when you type in, usually everyone recommends Python. Okay. And there are a lot of tools in Python that you can do, which makes it really easy compared to other languages. I think I have a snapshot here. Let me show you. We will come back to that. You see on the left-hand side, same thing is being done. I think I have not. Yeah, I think. Let me see. Yep. It's doing the same thing. On the left-hand side, you have your Python code, but on the right-hand side, you have a Java. And you can tell, I don't have to tell you like which one is easier for you, right? Which one looks much easier or simpler?
It's the same.
Python.
Left one.
This one looks same with this?
On the left one. So
left one looks much easier, and you can tell that there's a lot less typing compared to this one, right? Where you have to put all of these things here.
If they're coding the same thing, yeah.
Yeah. But this one much simpler. And it's not just, I didn't just pick some use case where it has a lot of code compared to Python. If you compare anything with these two languages, it's always going to be Python. It will look much simpler than compared to Java or C or whatever the other languages. Okay, so you might be wondering, I'm not sure, are you guys wondering why we have these languages? And so because somebody already asked the question, which language is best for to basically create your own operating system, right? So like I said, right tool for the job. Do you guys know what this is? What's going on here? Because I specifically picked this picture, this analogy to be able to explain the programming languages. I really hope that it will make sense to you, but we will see.
So you translate?
Yeah, translation is going on, right? These are the translators. I think it's called the simultaneous translation or something like that. Same thing with the programming languages. When you are doing Python or JavaScript development, or you are writing some programs in Python or JavaScript, those are slower compared to C, Rust, or C++ or Java programs. Why? What is happening is here, if I give you the analogy from this translators, whenever a person talks, they basically have to translate it so the audience probably understands what they're saying, right? And it's happening simultaneously in this case, correct? Do you guys understand what's going on?
Yes.
Yeah.
Okay, so it's comparatively slower as compared to what? Let's say I have a bunch of text files, and I give this text to a translator so that they can translate it to, let's say, from Russian to English, right? Once they translated it, it's really easy for English person to just read it and it's faster, correct? But every time I need to, let's say, translate from Russian to English, if there is someone in between us, let's say I'm speaking, I talk Russian, and on the other side, there's a person who understand English. And in between us, this translator. Every time I speak, even if I say the same things again, they have to translate it. And there is some latency going on between us. But if I just translate everything that I want to say and translate it into English, it's much faster, right? I can just hand it to the English speaking person. They can read it. They already know what I'm trying to say. Does that make sense?
Yes.
Okay, so in this analogy, Python will be the Russian speaking guy, and we have some interpreter in the middle. And on the other side is your computer that understands what this interpreter basically translates it to. But in the languages like C, C++, or let's say Rust, they don't have this intermediary. They already speak English, okay? They don't need any translation happening. Although there is a translation happening, but it looks much more like the analogy that I just gave you. You have a text, you give it to an interpreter, you lose a little bit of time when they translated it. But once you translated it, every time you need to do the same thing, you don't need that intermediary anymore. You already have that English text. Does that make sense, guys?
Yes.
So Python, JavaScript, all those languages that needs that interpretation, they're much slower compared to other languages that are really close to the computer languages, okay? That's the main difference. Does that mean Python sucks or JavaScript sucks? No. As you just saw, I already mentioned it. Python is being used in a wide variety of fields: data science, data analytics, DevOps, web development. Like I said, even YouTube that you watch, some of their code are, they were written in Python as well. Okay. Any questions about these programming languages, or why do we need the programming language, or anything about what we've covered so far, hardware, software? Anything? We're already over time. Okay, that's fine. So now that we covered that, we know what tools and what we need to be able to, create a software or program, how it actually happens in the background, how people or companies are building these programs or software. we need some sort of a process, right? So that we can keep track of what's going on and where we're at in building some software or anything related to development. That's where it comes in. This term here, SDLC, this basically stands for Software Development Lifecycle, okay? I'm not going to go into much detail because other presenters will be covering this figure, this shape that you are seeing here, and they will be covering about this shape that you are seeing here, okay? So it will make much more sense. But I just want to mention that we need some sort of a process to be able to build an application. What is happening? The first thing that we do in software development, we just plan it, what is needed and what is not. Then we do the analysis part where we take the requirements of the user or whoever is using our software. Maybe they say, like I gave the example of a website last lesson. They're gonna say, you know what, I need a button here, I need a table in here on the left-hand side, and at the bottom, I need something else, right? So that's where we do analysis. Then developers usually they do the design, how they gonna do it, if it's even feasible, what needs to be done before that, all that stuff. And actual implementation, actual writing the code is actually happening in the implementation part. And this is where, the testing and all that stuff goes on. Like it could be QA, it could be software developer who is actually writing this unit tests. We call them unit tests. And S-tests as well. Then we have this cycle where it says maintenance. We make sure that, program is behaving the way it is, or if there's some issues happening, we address that. It basically, this cycle goes on and on and on until we deliver fully functioning software. It doesn't have to be fully functioning software. We just pick some feature that user requested. Let's say they say that, you know what, when I click this button, I want the screen to be full screen. I need that feature, right? So it's only one feature. We can just implement that feature and it will be a deliverable, meaning we can tell the user that this feature is done and they can start using. They don't have to wait until the whole thing is being done. Same thing is happening. You started using your Instagram, you didn't have all these features, right? Where you can put the filter or reels and all that stuff. Gradually, they were being developed and implemented, and they were delivered to the users. Does that make sense, guys? Do you guys understand what's going on? Like, so all these steps, we don't say, like, we don't just get up every morning and in the meeting, okay, you know what? We will be doing the planning phase now. 2 days planning phase, 3 days analysis, or 4 days the design. It doesn't work like that. We just say, you know what, I'm working on my ticket, the task that I was given, and I'm doing analysis. I'm trying to understand what is needed. When I know what I need to do as a software developer, I start designing, implementing, and doing the testing to make sure that, it is actually working as it was requested. Okay? Any questions about these? Like I said, these will be covered in probably greater detail with Ernest. You can also ask him questions. Same thing happens in DevOps as well. You have some sort of a, process where you do specific tasks. Like in here where it says plan, what else? Operate, deploy, whatever the application, and all that stuff. So these might seem like a complicated topic, but it's really not. It's just a process. Same thing you would do. Actually, let me go back. I'm not sure if it's going to make sense to you guys, but if you think about the road today, transportations, all the highways and all that stuff, right? I think we can make an analogy in terms of a DevOps. DevOps would be the people who are making sure you have all these roads fixed, you have available highways and all that stuff. And let's say you are manufacturing a car. Before you let's say Toyota or Lexus or any other company, doesn't matter. When they build a car, they have to test it somewhere before, getting them on the public available roads, right? They probably have some tracks where they can actually test their cars before, releasing it, right? So all those test tracks, all these highways, roads that are available to you are maintained by DevOps. If you think about the shopping experience, let's say on Black Friday, you want to shop on Amazon or any other site, what do? There are a lot of users trying to shop or trying to buy something, right? There could be millions of them. So what do you need? You need to make sure that your website or your application is actually responding to it, right? So that you don't lose actually business, so you don't lose money as a company. It could be Amazon or Adidas or anything else. So what do? If you wanted to be able to handle all these millions of users trying to shop, you need some higher speed places, right? Where you can drive. In our analogy, it could have been the highways where you can drive your car, meaning all these customers that they can, during the peak hours, you will have a lot more service as opposed to regular days. If we come back to this and into this picture. So let's say it's not the Black Friday season or whatever. Maybe a company A or B, it doesn't matter. They need 10 servers so that their customers can, buy something or watch video. It doesn't matter what it is. But when it comes to Black Friday, there are a lot more customers compared to the regular days, right? On that time frame, that there will be some peak hours where there will be a lot of shoppers. So instead of having 10 servers, you say, you know what, I'm gonna need like 30 servers. That's how you scale it up, and all these DevOps engineers and all of them, they're working hard to make that possible. I might have lost you guys. Are you guys following? Does that make sense? Or I tried to come up with some analogy, but did it make sense? When I gave you an example of shopping during the, let's say, Black Friday or whatever could be, it could be Christmas or New Year, it doesn't matter. Usually those times are where you have high traffic, a lot of people trying to, add some, let's say, computer or whatever to their shopping carts, and they want to check out, they want to buy it. If you were using 10 servers and they were able to handle, let's say, 10,000 people when they're shopping, but once you have a peak hour during the, let's say, Black Friday, maybe you have 100,000 people. Those 10 servers will not be able to handle all that traffic. You basically will lose some business, money. People either will not be able to add to their shopping carts, or they're not going to be. You've probably witnessed it a lot, because I've seen it a lot, where you have added to your cart and everything else. The moment you try to pay it, actually check out, it gives you some error. It tells you something is not working or whatever, right? That's what is actually happening. It's not able to handle all that traffic. So companies usually scale it up, their servers and all that. Another question, when I say instead of 10 servers, they will have, let's say, 20 servers. Do you guys understand what I mean by that?
Yes.
Okay. What do you think happening?
So just the amount of the servers are bigger, and probably work was done is bigger.
Yeah, that's a good point too. You can maybe increase the memory or something like that, right? On one server or 10 servers. Or you can have 20 or 30 servers. What does that mean is, let's say on all those 20 or 30 servers, your application is actually installed. If you are watching Netflix or whatever, instead of those 10 servers, on all of those 30 servers, Netflix is installed. I mean, I'm giving you an example in terms of installed, okay? the regular application, the way you actually install them. But that's what is actually happening. So when you are, so I'm trying to, I'm trying to give you the example so that it all makes sense. Like we talked about the cloud, and we said that we're renting actually these devices, right? We're not actually next to these hardware, these servers or whatever, data center. The tools that make you, the tools that make it all possible to scale this up from 10 servers to 20, we learn all those tools in DevOps Bootcamp that make it possible for you to scale it up from 10 to 20. Even there are things that you can do. You don't even have to scale it up during the, when it's Black Friday or something. It will automatically scale it up for you. The moment it detects that there is a lot of traffic, let's say it's used to for 10,000 people, the moment it detects that there are more than 10,000 people or 100,000 people, it will automatically spin up. It will automatically start those extra servers for you. That's what DevOps does. Does that make sense, guys? I'm trying to explain it in really simple terms as possible. Okay. Same idea. If I were to ask you an analogy, if you understood, what analogy example you can give me in terms of the scaling? Anyone? Anyone wants to guess or give an example of what this scaling might look like in some other places?
Like engines for airplane, like as many as engines you got, like the plane fly very well.
Maybe not. I'm not sure. Let's go a little bit down, like in simple examples.
Maybe like a restaurant, when they open the new one, there's a lot of customers, but in the future they get more customers and hire more people to, how to say,
Was it Isaac?
what
Was
is
it?
that?
Who is talking? Isaac?
Zoom user. My name is Jibek.
Okay, Jibek, that's a great example. That's exactly what is happening. Did you guys understand the example she gave?
Yes.
When there are not many customers, you don't need all those waiters, right?
Right.
So you probably already collected some data, and you know your busy hours. You know when you are expecting more customers. That's why what do? You schedule the waiters' hours. Given that data that you have. Maybe you have a lot of customers during the lunch hour from 11 a.m. till 2 p.m. That's when a lot of your waiters come in, right? Once they go, you say, you know what, your shift is from 11 a.m. till, let's say, 3 p.m. Because you don't need all of that, right? Same idea is going on in here in these data centers. Using tools like Kubernetes and all other tools, they automatically scale up whenever they detect all of this traffic. Does that make sense? Even if you were, let's say, cooking something, cookies or something like that, maybe you got really popular and there are a lot of demand. What happens when there's a lot of demand? You just hire some more people and you bake a lot of much more cookies to be able to sell and to come up, to be able to meet that demand. Okay? That's the basic idea, what is actually going on in these data centers. Same idea. Yeah, that's a good point too, Akılbek. That's a good example too. He's saying like trains in rush hour coming often. We actually see all of them, right? Because they have the data and they do it purposefully. During the rush hours in the mornings and in the evenings when people are going into the downtown or coming down from downtown, there are a lot more frequent trains as opposed to the lunchtime or any other time or very late in the evening. Okay, I hope that makes sense. With that being said, all of the stuff you will probably hear more in the next days. So these are the tools that came to my mind that are commonly used by all the fields. So like I promised the last lesson, if they tell you they don't learn this stuff, they will be lying. Okay. But the thing is, depending on your field, depending on the thing that you've chosen, SDET, QA, or DevOps, it doesn't matter, database, scientist, or whatever, you will be expected to know a little bit more depending on your role. So QA may not know much about the Linux, but they still have to know some commands to be able to navigate inside the Linux boxes, those servers basically. Nowadays, you need to understand at least should be able to deploy your application to a cloud, meaning to those servers that you have just rented. And Docker, Kubernetes tools, Git, this is 100% all of them they have to understand and know. And like I said, languages and all that. Okay? This doesn't mean you have to know ins and outs of all of this. Like I said, maybe I don't even know this 100%. I know only the parts that I'm using. Okay? Same thing, database, same thing, Linux, cloud, or whatever. Does that make sense, guys? Because I think we're done for today. If you have any questions, I would like to take some time and answer those. If you don't have a question, see you guys next Monday. I think it will be Akshol with you guys, and then Betul, I believe, and then Ernest, and so on. And I
have a
hope,
question.
yes, please.
If I want to work as a software engineer, I have to have a bachelor's degree?
No, in today's world, you don't have to have any degree at all.
Okay.
It all depends on what you want to become. But if I were to tell you, so from all these fields that we've talked about, I think software engineering would be the hardest. I can tell you that. But if you say web development, even web development is really hard, I think, these days, because there are so many frameworks coming out. Like I said, someone asked the question last lesson, if we are keeping our curriculum up to date with the industry. And I told you that there's a difference between trend and the hype, right? If companies are hiring and looking for some specific tools, then we update our curriculum. But if some tool is just gaining traction and if it's just a hype, we can't just include it because it's going to be useless, right? If the companies don't use it, that doesn't mean it's trending.
Yeah, that makes sense.
Yeah. Because at the end of the day, we're all here trying to get a job, right?
Yes.
After you get a job, after you get better, after you get more comfortable, obviously you can become a, what do you call it, freelancer. You can just do freelancing work. And at that point, it's up to you what do you want to do and from where you want to do. What's my recommendation? She's asking, Bakhtigul. So what's my recommendation from what? Mac Pro or Linux? I'm a pro Linux user, so I cannot say Mac. Although I'm using Mac here, it's a 10X laptop. But on my personal laptop computer, I use Linux.
Mr. Sadar, can we install the Linux to Mac? Or we gotta buy some another Linux company? And
So Linux, if you happen to have one of those latest Apple MacBooks, if it's a Apple Silicon M1, M2, M3, or something like that, it's a little bit hard. There's only one Linux distribution, I think, right now that is compatible with it. It's called Linux, Asahi Linux. Okay. That sucks. You see, that's what I mean by proprietary, right? It's closed source. So they don't share all the information that needs that can, the Linux developers or maintainers, if they had access to how to interact with that hardware, they would have made it possible. But since Apple is proprietary, they keep it close. It's a secret. All these developers, Linux maintainers, they find a way to make it work by testing, failing, testing, failing. So Linux Asahi is your best bet right now if you want to install Linux on a MacBook Pro. If it's latest versions, if it's Intel versions, obviously you can install Linux.
And Linux can install to any base motherboard computer, right?
Yes, the other, I didn't go into much detail, but Linux is really lightweight. It doesn't consume a lot more resource as Windows does or Mac OS because it doesn't run some tracking software or whatever in the background. So you have all the control. And to answer Bahtigul's question, Pro Linux or in our DevOps bootcamp, we require people to have MacBooks because it's the closest you can get to Linux. And also there's a lot less problems when we're, installing some tools and all that. It's really popular in development environment in general, Mac OS. In web development, in software development, and most of the companies, I think they give MacBooks. So your best bet is probably MacBook if you like. But like I said, I use Linux. And why do we require to have MacBooks? Because if you run into some issue here, if everyone has different computer, it's really hard to be able to help. Like I said, with Windows, I didn't go into much detail, but if you open it up, I already showed you this terminal. This one is really similar, almost the same as a Linux. But on Windows, it's really weird. So we don't want to deal with all of that stuff. And plus, you need to get used to at least MacBook because, usually companies, they will provide you MacBooks. At least at my company and every other places that I've seen, they're usually MacBook. Yep. Anything else, guys? So was it helpful today or was it too much information for you guys?
It was a great.
I hope you understood what we've talked and covered. So these are the basics, and these are the stuff that we start the first week or something in our DevOps bootcamp. Obviously, there's a little bit more maybe than this, but we try to cover the basics first so that people understand why we're doing it, why we're using Linux, or why we're doing a virtualization or whatever. So we need to explain the problem and show the solution, right? Otherwise, if you don't know the problem, what the problem is, then it doesn't make sense. You will basically not understand why do you even need this tool? Why are you using Linux as opposed to something else? Or any other tool. We need to understand it so that we can make some decisions whenever we need to use some tool versus the other one.
I have one question.
Yes.
So before you were explaining us about the motherboard and all of that, right? The hard drives, so all
Yes.
that. So being a DevOps engineer, do you deal with that knowledge like on a daily basis or just like for the general information?
This is, like I said, general information, guys. You will not be, I don't even think anyone asks you. So this might be, I don't think anyone asks you, do you know what RAM is or whatever, okay? Why? Because if the company you get a job at, if they're some who asked the question, if they're on-prem, and if you happen to be a hardware engineer or network engineer, then you will probably need to understand all of this stuff. But like I said, most of the companies, they rent, right? They use the cloud, Google Cloud or whatever. So Google's engineers, Google's employees, they take care of all of this. You don't do anything. You will not even know where your software, your application is running. You don't even know which data center it's in or where that data center is, okay? All of this is abstracted from you. People are taking care of that. If they need to update or replace this hard drive, someone else is doing for you.
Thank you.
Yep. We just give it as a general info so that you at least have some understanding of, what is actually going on, something like that. I didn't cover, actually, I forgot, but it's not a big deal. How, whenever you click on your application, what actually happens, but that's fine.
I have a question. Yes. First of all, thank you so much for this course. It was great, actually. I enjoyed it.
Thank you.
And I actually have two questions. So first of all, is like DevOps workers, are they basically like a customer service for like a remote customer service for all the actual thing going on in the server? Like when we have problems with Wi-Fi or with TV, we call the customer service and they guide us, right?
Yeah, those are called help desk. This is not like that. DevOps.
What would be the duty?
Yeah, so DevOps are the people who are giving us all these infrastructures. What do we say with the infrastructure? By infrastructure, we mean all of this stuff. What is that? All of these things. They're making it possible, for us to be able to deploy our application and all that. If you remember, I gave you... Sorry, who was talking? That's why I gave you the example of the roads and highways, right? So imagine you built a what is it called? You built a bike, or you built a car or truck or train or whatever, right? So you have some product in your hands, but if you don't have roads or for trains, all those train tracks or whatever, is it usable?
Well, no.
So you need roads and highways, right? To be able to make use of your product that you've just built, correct?
So do we use programming language to build this road?
No. DevOps, they don't.
How we build it?
They don't do it. So DevOps, basically the people that are, giving you that infrastructure so that you build your car so that you can drive on top. How they do it, like I said, there are some tools, Kubernetes and all that other tools that DevOps will, spin it up and maintain all of this stuff for you. They make possible for software developers and all QA testers to be able to play somewhere, test their software somewhere, okay? All of that is being done by DevOps. So if you pay attention here, if we go to this picture at the very end, it is not like, if you get that impression that we can live without the DevOps, or we can live without the testers or QA, or let's say software engineers, it's not like that. We all each depend on each other. That's why I started this info sessions by talking about all of this big data that we are producing every day, every second, every minute, right? It's not possible for only one field or one title to be able to manage all of this stuff. I'm not sure if it made sense or not. Did it make sense or no?
It does, but I think future courses will explain more in detail so we can understand better.
Yes, so that I specifically didn't go into all of this stuff because why? I don't want to, step on my other colleagues' topics, because they have these topics which will explain in more detail. Like Betül,
Yes.
Betül has a lot more detail about all these fields in the DevOps: network engineer, cloud engineer, what else? DevOps engineering, or whatever engineering in DevOps, okay? She will have a lot of information. And also Ernest, he is working as a senior DevOps engineer as well. So he will explain you how we all communicate between each other. So how DevOps communicates with software engineer, or how they communicate with QA or SDETs. and how we depend on each other, actually.
Yes, that's what I was wondering actually.
Yeah. All of this will be covered. I just don't want to go into more detail.
All right, thank you.
Yep. Any more questions?
Yes, hello everyone, this is Olga. I would like to ask you about the market. So last session, you told us that we are expecting some data online increase, right? So we do need DevOps in all of this system, and I do have a question. Why we heard a lot about layoffs, for example, last year, and why we do see that some graduated students from the STEM tech school are looking for a job for 6 months, for example. Is it depends on their people, personality, or this is just specific on the market right now? What do you think about this? Because I don't understand why we're expecting, this increasement of data, online data, and we do need DevOps, and we do need, at least, maybe not at least, but around 6 months for employment.
Okay.
I would like to know your opinion regarding this.
Yeah. So this is a really great question, and it's a deep question actually. Like I said, I don't think I mentioned there will be a lot of positions or something like that. I don't think I mentioned anything like that. But with one of the speakers, specifically Yulia, she will be giving you the numbers about the DevOps position compared to, let's say, STET or QA. She will have more information about all of those processes, right? Interview processes and self-confidence during the interview processes and all that stuff. But so I'm not going to go into that a lot. But in terms of why layoffs happened because with the start of the pandemic, I think there's a political side of it as well. I'm not too current on that, but I think what happened is companies basically started, hiring a lot of people, even if they didn't need it. Okay, that's what it actually happened. And once the COVID was over, market started actually correcting itself. So companies actually started laying off people because they hired them in the first place when they didn't even need them. Okay, that's why there was a little bit of boom happened in the 2020 and 2021, I believe, and people were just passing the interviews without much of knowledge and all that stuff. And if you have guys watched one of the latest posts on Instagram, two of our students, they actually speak the fact how they're doing right now, and if it's easy, if it's hard, and all that stuff. They're talking about all of that information, and we're not hiding any information. What has any one of you watched the one of those latest posts on Instagram on TEDx website? I mean, the page on Instagram.
Yes, I did.
Okay, what does she or he says? Obviously, it's not easy.
The most interesting information for me is just to see that this guy, for example, from batch 8, and
Okay.
I do understand that is around 6 months ago, graduated. So, and I understand that any specific position, there are a lot of specific questions during the interview. For example, cloud engineer and DevOps itself. So I do understand that we will have a lot of options for, just to choose our future position. But anyway, I just wanted to know your opinion.
Yeah. Okay. I'm not sure if I completely understand it, but what happens is usually in all boot camps, I'm guessing, students basically don't have confidence. They don't even apply to jobs, right? In the first place. If you don't even start applying into jobs, what is the chance of you getting a job?
0.
0, right? I understand them. I mean, I've been there. I'm being totally brutally honest with you guys. I've been there. Whenever people it's normal that you don't have a confidence. You feel afraid. You feel like you're not ready, but you have to start from somewhere. If you don't apply at all, how on earth these companies are supposed to find you? Or I'm not gonna go into a motivational speech where you probably heard millions of times. How I don't know, Alibaba's CEO or someone who applied 500 times or whatever, or someone else applied 500 times, they never gave up. In the end, they were able to do something, right?
But what?
So
Why
all these
this
questions.
happens during the education at the bootcamp? For example, we all comes in and with a good motivation, we all wants to get a better job, and we're very positive. And by the end of the education, we are not confident. Why? It
Yes.
depends on the people. Why we are disappointed with this? Because right now it looks great. Yeah, we're so excited and so motivated. But what happens in 7-8 months by the end of education?
That's a great question. What I can tell you, people, even today, people for some reason they get afraid, or whenever they see a challenge or they struggle, they automatically, which is normal, I understand that, they automatically fail. I mean, they automatically start giving up. I'm gonna be honest with you guys here. With I'm not sure if any other bootcamp can tell you this. If you need a motivation, constant motivation, if you think it's going to be as easy as cooking a cookie or something like that, right? So I can tell you that, right? If I wanted to invite you to our bootcamp, I can tell you that. Don't worry about it. It's going to be super easy. You will get 100% job. I can tell you that. But is that what you really want to hear? Because most of the time, people don't want to accept the reality, okay? So if you were, I'm not sure who asked this question. So if you were an employer, if you had a company, if the job was super easy, would you be hiring a person and paying at least, let's say, starting price $120,000 or whatever, $120,000? Will you be doing that as a business owner?
Okay, and the next question: how to understand if it's
No.
for example,
Before we go into the next question, if you were a business owner, will you do that if it was a super easy that anyone can do?
Of course not.
Of course not, right? So we have to set our reality and our expectations right, and we have to stay positive no matter what. And I'm assuming all of them, like, trust me, I have 2 kids. I know what you feel. And there are so many tons of boot camps. I understand that. It's really hard to pick. You don't know who is, lying, who is telling you the truth. I understand it. Trust me, I am being honest here, okay? It's not easy from your perspective as well. Like I said, there are tons of boot camps. But the problem is, you have to stay focused. You have to dedicate some time. Like I said, if it was super easy that anyone can do, why would you pay $120,000 starting price? No one. And I'm assuming most of us here are parents or people who are trying to make a better living for their, loved ones or for the families. Okay. And I literally understand that. I've been through all of this. You can trust me on that. I'm not lying. Like I said, I would have said, you know what? Don't worry, just come in. It's super easy. I'm not telling you that. Nor our students are telling it on Instagram. You've seen it. What they're saying, it's not easy, but it's not impossible, right? What else they're saying? You have to dedicate some time. You have to stay focused. You have to try. The first time you see some challenge, you shouldn't be giving up. Okay. It's the same thing in the real life. Unfortunately, I mean, no one can tell you the otherwise. What's your next question?
No, that's it. Thank you.
Okay. Do you guys have any questions regarding any of this? Or since we already opened this topic, and I think, yeah.
I just wanted to add something because that's
Sasha, no, we don't have accreditation right now, but I think we might be working towards that. About the bootcamp accreditation. What was another question? I'm sorry.
it was not a question. I just wanted to add something to whatever you were saying because
What?
the situation that you were explaining is that exactly what happened to me.
Uh-huh.
That was in a different bootcamp over for like, I was doing the software development almost for like 2 years.
Okay.
Later, when I was knowing like the few languages, the HTML, CSS, React, JavaScript, and all of that, and just trying to find a job when I was really in the market. And the reality was a little different than I expected. And I understood that first of all, I'm tired coding and I don't want to do that, like coding all the time.
Uh-huh. Okay. That's good. If you know what you don't like, then now I'm assuming you want to become a DevOps or SDET or QA or whatever.
I'm not saying that IT totally it's not mine. It's okay, it's doable. But just
No, what I'm saying is
field is different.
Yeah, that's what I'm saying. You know at least that you don't want to do software development. And
Yeah, I
you
know that I hate coding. I hate languages. I know that for
Yep.
sure.
Okay, yep, that's great actually. So because you already know, because right here, if I say right now, I know for sure that 70% or 50% of you, you're not gonna trust me because I'm representing TenTech here, right? If I tell you, you know what, software development is hard, don't do it. Or if I say business, what is it called? Data scientist, it's hard. You have to have a mathematical background, strong mathematical background, statistics. You're probably not going to believe me because you will think that I'm trying to make you not go into those boot camps to data analysts or data scientists or whatever. I'm not doing that. I'm telling you exact truth. If any one of you in here have been in those fields, like Dinara, I think it was Dinara, right?
Yes, that's me.
So she's been through the software development and whatever. Now she knows that maybe she knows the struggles and she knows at least she doesn't want to code all the time. If we had some other folks from data scientist world or whatever, or at least people who have tried, maybe if they were honest, they would have confirmed what I'm trying to tell you. Like I said, I'm not trying to, if I wanted to keep you so that if I wanted to make sure that you come specifically to our DevOps bootcamp, look at the time. What time is it now? It's 8:20. And this info session was planned for between 6 and 7 p.m. for 1 hour. And I'm over 1 hour and 20 minutes. I'm here, I'm trying to make sure that you understand what is going on and what I'm trying to explain you. Does that make sense?
Is there everyone like you?
You can ask them. And like I said, I've just started. I've taken the role of making sure our curriculum is up to date. It's great. Our instructors up to, let's say, standards, and they're making a good job. As you know, you will not be able to satisfy 100%. There always will be people who are not gonna like me, or they're not gonna like someone else. There always will be like that. You see, I'm talking you the facts here. But most of our students are happy, and I'm here to make sure that this bootcamp thrives even more. And I will do whatever in my power to make it happen. If for some reason I feel like I'm not doing a good job, I have no problem with saying, you know what, I'm not able to do it. I don't want to do it. Just let someone else do it. Okay? I hope that makes sense. I'm not sure I can change your mind, as you know. I'm just trying to be honest with you here.
Can we actually hear more from Dinara about her negative experiences? Because she just started telling and then it got distracted.
Oh,
Like,
okay.
what exactly was the problem? Because she said she had been in a different bootcamp and then she was doing coding. Like, I would like to hear if she wants to share with us.
Please. I have no
Not a
problem.
problem. So coding, it's logically hard. Like, let's say the understanding and just remembering all of that, it was hard for me. Then the other level of like already getting in a job, okay, I was getting a calls from my recruiters, everything was fine. But then they were sending me the tests that were different than I expected. And it's not the bootcamp's fault, it's just the reality. When you're like on the LinkedIn and you see different things, you understand that maybe I was not enough confident, or I don't know. But it's just my thing. I understand that I start doing it over and over and over, and even going through that tests and even explaining them my knowledge and all of that, I understood that I don't want to code that much how you're like supposed to do that in a position. That's for my thing. And then I just stopped doing that. And then I decided that I want to do something different. I have enough knowledge to do something else. I'm not saying maybe in later, hopefully, I would know something more and I would use these languages that I still remember. But
And
I
I
don't
can guarantee you will. Sorry for interrupting, but it will help you a lot.
maybe, I
But
don't know.
I just wanted to clarify one more thing, okay? Just to make sure, so that I don't leave any room for any rumors or whatever. Dinara Gambetova. Do I know you?
No,
Have we ever met or
no,
anything like that? I
no,
have no idea who this person is, okay? So I just want to make clear that it's not some person that is, coming up from here and trying to make look some, software or whatever, look bad. I have no idea, no clue who she is.
Oh, no. That's just my thing. That's just my experience that I had. I was dealing with that for 2 years. I spent 2 years on it, and I'm just done with it. That's just only my thing.
Yep.
I would be happy to have a great job and make a lot of money right now, being honest.
Thank you much, Dinara, for your input. Like I said, guys, I hope it was informational and hope you had some. So Pervana is asking what kind of bootcamp you went. What did you study? Okay, I don't want, like I said in the first lesson, I don't want to mention any other bootcamp. I don't want to trash any people.
Sorry, guys, I'm so sorry. It was not in the US. It was in Canada, so it's not even US thing. It's a Canada.
Even
Yeah,
if
the only thing I wanted to know, was it software engineer or something else? Because you said you started doing a job as a software engineer. Can you do it just going to a bootcamp, or you have to study at university? That's what I was wondering.
Okay, my thing was front-end development first.
Okay,
Yep.
thank you.
Thank you, guys. Anything else? Like I said, as you can see, I have no problem letting some other people to give their input. I'm not trying to mute someone or I'm not trying to hide anything, okay?
Thank you.
Someone, yeah, someone.
Thank you, Sardar, for answering tricky questions and give us a chance to talk each other and share experience. Thanks so much.
Sure. Like I said in the first session as well, I want to make sure that everything is clear. You guys know what it is, what it is not, so you make the informed decisions. Okay, guys. I'm not hiding anything. And somebody asked, how do you actually teach, and how confident are you if your bootcamp is good or not? Like I said, I'm teaching Linux, Python, what else? Git, and some of the scripting. If you are ready to take the knowledge, if you are ready to be overwhelmed with the knowledge, I can give you all those knowledge, all this information. Okay, about Linux, whatever you want to learn about the Linux, I can provide you as long as you are ready to receive that information. I have no problem with sharing and explaining all that details. Okay. Thank you guys. Like I said in the first one, this one even more interactive, and I really loved it. Okay. One last thing I want to ask you is to be the same way in the upcoming sessions.